C, a powerful and versatile programming language, emerged in the early 1970s from the Bell Laboratories. It was designed and implemented by Dennis Ritchie. Ritchie sought to create a language that provided low-level control over computer hardware, while maintaining portability across different systems. C was initially developed for the Unix operating system. It quickly gained popularity for its efficiency, flexibility, and close-to-the-metal capabilities. C's simplicity and elegance stem from its concise syntax and powerful features. The language provided programmers with the tools to write efficient and portable code. This code could interact directly with hardware. It gave developers an unprecedented level of control over system resources. C's impact on the world of computing cannot be overstated. It laid the foundation for countless software applications, operating systems, and embedded systems. It continues to be widely used today. C's influence on the landscape of programming languages is profound. Many modern languages, including C++, C#, Java, and Objective-C, draw heavily from its syntax, concepts, and principles. C++ extended C with object-oriented programming features. C# and Java, while designed to be platform-independent, retain similarities to C in their syntax and control structures. This lineage is evident in their use of curly braces for code blocks, semicolons to terminate statements, and similar data types. C's influence can even be seen in scripting languages like Python and JavaScript. These languages, while dynamically typed, often adopt C-style syntax for familiar constructs like loops and conditional statements. C's enduring legacy is a testament to its enduring relevance and the power of its design. Its influence continues to shape the way software is developed today. One of the defining characteristics of C is its compilation process. Unlike interpreted languages where code is executed line by line, C code must be compiled into machine code before it can be run. This compilation process involves several steps. First, the C source code is passed through a preprocessor which handles directives like #include and #define. Then the compiler translates the preprocessed code into assembly language, a low-level representation of the program. An assembler then converts the assembly code into machine code, which is specific to the target architecture. Finally, a linker combines the compiled code with any necessary libraries to create an executable file. This compilation process results in highly efficient code that can run directly on the hardware, giving C its reputation for speed and low-level control. Section 4. Deciphering the language syntax and data types. C's syntax is known for its conciseness and clarity. The language uses a combination of keywords, operators, and punctuation marks to express program logic. A C program typically consists of one or more functions, with the function serving as the entry point for execution. Each statement in C must end with a semicolon. Curly braces are used to group statements into blocks, such as the body of a function or a loop. C provides a variety of data types to represent different kinds of information. These include integer types like and for whole numbers, floating point types like and for numbers with decimal points, the character type for representing single characters, arrays for storing collections of elements of the same data type, and pointers, which store memory addresses, are a fundamental concept in C. Section 5. Getting started with C tools and practical examples. To start programming in C, you'll need a text editor to write your code and a C compiler to translate it into an executable program. Popular C compilers include GCC, which stands for GNU Compiler Collection, and Clang. Let's create a simple Hello World program in C. First, open your text editor and type the following code. Next, save the file as. Then open your terminal or command prompt and navigate to the directory where you saved the file. Compile the program by typing. This will create an executable file named Hello. Finally, run the program by typing. You should see the output, Hello World. This simple example demonstrates the basic structure of a C program. From here you can explore more complex concepts. C offers a wide range of libraries and tools for tasks such as input/output, string manipulation, memory management, and more.